Hello everyone, I'm Paul and today we're solving problem 38, count and say. So in this one we're given an input n and we need to return the nth element of the sequence named count and say. Now this sequence is built with the string compression method that works like this. The first element in the sequence is 1. Right now we are trying to find the second element, so we are counting every consecutive equal element. In this case we only have a 1, so the count of consecutive elements stays at 1, and we want to add here that count plus the element itself in a string format, so this would be 1 and 1. Now let's find the third element in the sequence. We need to find the count of every equal consecutive digit in the previous element of the sequence. Here we see the 1 2 times, so we add here 2 and the element itself, which is a 1. Now we are trying to find the fourth element in the sequence. Here we have 1 2, so we add 1 for the count, 2 for the element. Now we are here and we only have 1 1, so we add 1 for the count and 1 for the element. So do you get the idea? We are counting every equal and consecutive digit and we are appending each time that count and the digit itself. So let's say now we are in the fifth element in the sequence and we have 1 1, so the count and the element. Next we have 1 2, so the count is 1 and the digit is 2. Next we have 2 1s, so the count is 2 and the digit is 1. Let's do one more. Now we are finding the sixth element in the sequence and here we have 3 1s, so the count is 3 and the digit is 1. Next we have 2 2s, so the count is 2 and the digit is 2. And next we have 1 1, so the count is 1 and the digit is 1. Okay, so we are given an input n and we are trying to return the nth element of the sequence. So let's say n is equal to 1, we want to return this one. If n is equal to 4, for example, we are returning this one. Okay, so what this means is this problem is all about how can we pre-process all of these elements in the sequence. And there are basically two ways to solve this. We can solve this recursively from the first element up to the nth element, or we can solve this iterating from the first element up to the element 30, and every time we want to store each result or each element in the sequence in an array, and then we just need to return the nth element. First, let's start with the iterative approach. We will start outside this class because we are pre-processing the same values every time for every test case. So by doing this, we are saving some time. So first we will create an array initially with a 1, and now we'll say for I in range from 1 up to 30, current equals array of I plus 1. So this is the previous element that we are working with. N equals the length of the element. Left pointer equals 0, right pointer equals 0, and the result for this element is initially an empty string. And while the left pointer is smaller than n, count equals 0, and while the right pointer is smaller than n and the current character at the left pointer is equal to the current character at the right pointer, count plus equal 1 the right pointer plus equal 1. And next we want to add to the current result the count in a string format plus the current character at the left pointer, and we update the left pointer to the position of the right pointer, and we append to the array the current result. Okay, so we will do this 30 times or 29 times actually, and we will fill this array with every element in the sequence. And finally, here we want to return the nth element, so array and -1. This is the entire code, and I guess this should work, so let's see what happens. As you can see, this works and it's very efficient. So now let's go with the recursive approach. Well, first we know that if n equals 1, we want to return a 1. This is our base case. And now we will create a result initially with an empty string, and we want to take the previous element in the sequence. So previous equals self dot count and say and -1. Left pointer is 0 and right pointer is 0. Now we want to do the same we did previously, so while the left pointer is smaller than the length of previous, count equals 0, and while right pointer is smaller than length of previous, and previous at L equals previous at R, count plus equal 1, right pointer plus equal 1, and we add to the result the count in string format plus previous at L. We update the left pointer and return the result. So this is the entire recursive solution. Let's see if this works. And it works. It's not as efficient as the previous solution because we are pre-processing every value from 1 up to n for every test case. That's why the previous solution was faster, but it still works. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.